So far, 2 chapters ago, you learned about converting between different quantities of elements. So for example, you learned how to convert between moles and particles, moles and liters, moles and grams, and then in the last chapter you learned about chemical reactions. So in this chapter we're going to incorporate both concepts and we're going to use chemical equations in order to be able to convert between moles or grams or particles of one entity, so for example a reactant, into moles, grams, particles of a product. And the purpose of this, the value of this, is that if we start with a certain amount of reactant, using our math skills and stoichiometry, we can determine how much of the product should be produced. But before we get into that, let's review some of the concepts that we've already talked about. Specifically, let's look at a chemical equation. So this is an everyday example. In order to make 5 pancakes, I need a cup of flour, 2 eggs, and half a teaspoon of baking powder. Remember that those 3 entities on the left-hand side, those are your reactants, while the one on the right is your product. So if I tell you I have 12 eggs and I ask how many pancakes can I make, if we do the proper setup, which I'm asking you to do even though it's an everyday example, I would start off with my given, which is 12 eggs, and then I'm going to convert into pancakes. So I'm going to put eggs on bottom, pancakes up top. Now here's the new concept. In order to relate pancakes and eggs, I'm going to use this chemical equation up above. I notice that there are 2 eggs required to make 5 pancakes. Okay? So 12 eggs will make 30 pancakes. So this is the concept that we're going to use. This is the only new idea in this section, specifically that we can convert from reactants to products by simply using the number of items. So for a chemical reaction, that will be the coefficient in front. So let's look at an example. If I give you this reaction and I ask you how many moles of ammonia are produced when 0.60 moles of nitrogen react, okay, the first thing that I have to do is I have to balance. Okay, so to balance, I'm going to put a 2 in front of ammonia and a 3 in front of hydrogen. Now I'm going to convert. So I start with my given, which is 0.60 moles of N2, and I'm going to convert into moles of ammonia, NH3. So I'm going to put moles of nitrogen on bottom, moles of NH3 up top. Now, here's where the recipe idea comes in. In order to make 2 moles of NH3, I need 1 mole of N2 and 3 moles of H2. So, if I want to convert from moles of N2 into moles of NH3, I'm going to put a 2 in front of NH3, and I'm going to put a 1 in front of moles of N2, because 1 mole of N2 is required to make 2 moles of NH3. And then all I have to do is multiply across, and I get 1.2 moles of N2. And that's it. This is the new concept. That's it. So we're going to add another step, and instead of just going from moles to moles, I'm going to go from, for example, grams of one thing into grams of another, or grams of one thing into liters of another thing. So let's see how I do that. So here is my diagram. So if I start off, if you notice, you've already seen each of these individual wheels. So for example, if I wanted to go from volume to moles, we knew that I had to use 22.4 liters equals 1 mole when we're at standard temperature and pressure. Let's say, for example, I wanted to go from moles to mass or mass to moles, I would use my molar mass. If I wanted to go from particles to moles or moles to particles, I would use Avogadro's number. So that's not new. If I want to go from mass of one thing into, let's say, the volume of another, the only added step is, well, I start with mass. I'm going to get into moles using my molar mass. Then to go from moles of one thing into moles of another, I've got to use my mole-to-mole ratio. And that is simply using my coefficients like we did in the previous problem. Now everything else is the same. So I go from mass to moles, moles to moles, and then I can go from moles into volume by using 22.4. Or I could go from moles to mass using molar mass, or I could go from moles to particles using Avogadro's number. So the only added step in this section is your mole-to-mole ratio, which is just your coefficients. All right, so we're going to look at a problem to make sure that all of this makes sense. So here I tell you that you have 5.40 grams of hydrogen, and I want to know how many grams of NH3 that would produce. So the first thing I've got to do is balance this, okay? And so I'm going to put a 2 in front of NH3 and a 3 in front of H2. I'm balanced. Now I'm going to put my given, which is 5.40 grams of hydrogen. Okay? So my goal, I'm going to start on the far left-hand side. I'm in mass right now. Grams are a unit of mass. So I'm going to go from mass, the mass of H2, into moles of H2. And so to do that, I'm going to put grams of hydrogen on bottom, moles of hydrogen up top. Then I'm going to go from moles of hydrogen across into moles of NH3. And so to do that conversion, I know that there are 2.02 grams of hydrogen, that's its molar mass, for every 1 mole of hydrogen. Now I'm in moles of hydrogen. Now I want to get into moles of NH3. So I'm going to convert. I'm going to put moles of hydrogen on bottom, moles of NH3 up top. Okay? And here I'm going to be using the coefficient. So for every 2 moles of NH3, I need 3 moles of H2. Now I'm in moles of NH3. I want to get into grams of NH3. So again, I'm going to convert. I'm going to put moles of NH3 on bottom. I'm going to put grams of NH3 up top. Okay? I need the molar mass for NH3, which is 17.04 for every 1 mole of NH3. Okay? And so when I do that, I'm going to take 5.4, divide by 2.02, multiply by 2, divide by 3, and then multiply by 17.04, and I get 30.5 grams of NH3, and that's my answer.